Good morning. We're going to talk about logarithms really quick. And so I posted a blank version. If you didn't see that, you might go look at it. So you could like follow along or just like in your notebook. Okay, logarithms are weird and that's okay. A logarithm is just a special way to ask a very specific question, right? So we like care about that in mathematics. So the form that we are going to see is this log. There's different types of log, but we're going to stick with this one. Log base b of a equals x. Oops, I don't want that little dot. That might be weird. Okay, so in words, what I want you to practice saying is like how to say this, right? Or like say it in the way that will make sense. Log base b of a is x. And then the other thing I'm going to do is I'm going to use a highlighter today. So let me actually get orange because I want orange. Oops. Orange and pink. Okay. So my base, is going to be orange. And then my a value, my amount, is going to be pink. So I'm going to use those in the same location. And then for my x, I'm going to use like a teal color. Where's my one teal color? You'll know what I'm talking about. So x is out here, right? So I have three components, and then I have this function log, which is like a newer thing for us. Okay, so back to the question. So the question that we're asking is, what exponent, so I care about exponents, what exponent is required to go, right, because it's like a function, to go from a base of b to reach I'll say the value of a, and I'll add another line. Okay, so again, my base is here, base of b, and then my value a, yeah? Okay, base b. So there's two forms that you're gonna be looking at. So again, I'm gonna use my little brown thing, and I hope I have space here. So for our exponential form, this is what we just sort of reviewed. You're gonna have your base, and that's raised to some exponent, right? It's something. It's a number or it's a variable. If it's a number, then you like know what's going on. Equals some answer. Of course, I don't have space for this. Okay. And then, so how that looks differently, for a log form is that now I have my log and I have my base. I'm going to write it out. And then I have some answer equals my exponent. I always run out of space, even if I'm on my sheet. Okay, so if we look at my bases, right? So here's my base. And then here's my base now over here. Yeah, it's that little subscript number. My answer is like my amount, my value. And so before I knew what that was, and then here it's going to be my like new input. My exponent, right? So that was my original input. Now I'm able to find that. So remember when we were talking about inverses, right? The input and the output switch, and that's sort of like an important part here. So I'm going to write that really quick. So I'm going to say like originally this was my input. But then here it becomes my output, right? Because they're inverse operations. So here this was my output. And now look, I have to input it. Yeah? And those are switching. Okay, cool. So the structure is important. And here, actually, let me sort of make this be. Okay. So I'm going to use highlighters. And if you had me in the past, you know that I use a lot of highlighters anyway. So just like be chill about it. So again, here's my A, my amount. And then that's going to match over here. My base, I'm using this orange color. And then for my exponent, my x, my unknown, I'm going to use teal. Okay, so let's look at two examples. So, oops, no, I don't want that. I want a pen. I want a pen. So log base 4 of 64. I'm going to do parentheses just because I don't want anything to look, too much here. And then let's do another. We're just going to highlight what we know. Log base 343, oofta, to this, or 7 equals some unknown. I don't know. Okay, so again, let's just work on our identification. So my base again is down here. My amount, right, that was my original output, is now my input. And then here's what I don't know. I don't know x. So I'm going to be able to find x if I run this calculation. So same thing working backwards. There's my x. Here's my amount. It's 7. And then I have a base of 343, which is like kind of a lot. So I'm thinking that might have to be a fraction. Okay, great. So that's sort of like just like looking at the structure, like what are things, just so we get all the numbers in the right place. For the exponential, hopefully this feels a little bit more comfortable because you've seen this more times. I mean, in theory. So 4 to the x equals 64, and then here's our 343 to the x equals 7. Yeah? So in this form, I should be able to see that my base is my base, right? It's the thing that is raised to the x power. Here's my exponent up here. And then here's my output, some amount. Yeah? Okay, so what's nice about logs is sometimes, like this one, you might not need a log to know the answer, or you could find it maybe like doing guess and check. Stuff like this though, right? Might be more time consuming to try to like sort that out in guess and check, or something like that. You could look at a graph, but ultimately we want to have a calculation. So like definitely for this last example, we'd want to use a log. Okay, next page. Oh no, my logarithm has no base. That's okay. So here's what we're gonna write. Right? Okay. So actually here, I want to maybe let's do pink. That's more fun. So anytime, and I know the pen click, anytime the base, so that little subscript of a logarithm, and I'm going to spell out logarithm, and I want you to try to do that too, just so you get in the habit of like spelling it out, because it's kind of a funny word to write. Okay. Anytime the base of a logarithm is not written, like it's not specifically identified, written, so it's like missing, it is assumed. It is assumed to be the number 10. To be the number, and again, I'm going to write this all out. 10. So we use base 10 in our culture, right? Like decimals, money, stuff like that. Okay, so for example, let me actually do this real quick. So, and we'll call this like 1, 2, 3, doesn't matter. Log 10, right? So if I put in log 10 to my calculator, it will give me something out because it is assumed my calculator is base 10. So what's really happening here is that it's like log base 10 of 10, and that equals 1, just for the record. And then the other thing I want to say over here is like why that's true. 10 to the first power equals 10. Yeah? Okay, so for the next one, it's saying, okay, log base 10, right? There's a hidden 10 there of 1,000 should equal what? 3, because 10 to the third power equals 1,000. Yeah? So see how, remember like when you're doing decimals way back when, oh my gosh, you're actually just like getting ready for logarithms. Isn't that so cool? Okay, log base 10 of 1/100th. So what would this be? Oh my gosh, it's gonna be negative because I would need a negative exponent to get that value. And I'm gonna write it like this because I want you to be careful. Yeah? Okay, so this is similar. oops, that's not how you spell similar. Idea to writing, you know what I'm going to say? Like 1x, right? Versus x. So it's just like, it's assumed to be there because of the way the log is made. It was like designed for this. I know, that's a trip. So that's true for that. Okay, so some calculators will change your base for you. There are log laws and properties, so that was in the slideshow. We're not really going to talk about those. We wouldn't do it even in a normal year, so I don't want you to feel like you're missing out. You'll definitely see those later, and they're usually, easily, well, not easily, it's kind of weird, but you can apply them. The other thing I said in class to someone was that like logs basically need exponent laws to like survive. So they operate under some of the same notions because they're inverses. So just think about that for a second. Okay, but if you have one of these beautiful calculators, like these are what we would have in my classrooms, and I know some of you like check them out, or maybe you have one on your own. Everyone will have a log button, that's true, and there's different logs you can do. If you have a yellow calculator, it will do, it's called pretty print. So you don't have to worry about change of base. That being said, I feel like it's a really quick calculation and it's good to know because sometimes you might be taking a test on a computer for admission into a college, and then you'll have just like a computer calculator, and they might not give you a good calculator. So change of base is important. So I put this little image down there, and so I'm just gonna again fix my colors, and then A is always pink. So if I have a logarithm, I want to like know what it is, then I can, this is like how I'm going to find it. And then there's like this little note here about M, right? So like for today, M is 10, right? Because that's what my calculator is. So I wrote that down there. M is 10 because like the calculator. And again, here's the button. This is the log button. Okay, so I want to do just like one example, and I feel like this might be in the other homework that I gave you, but you know what? You're fine. Okay, so let's say that we have an example. So, okay, here's one. Log base 3 of 2 equals x. Right, so remember that this would be like 3 to the x equals 2, so like solve for x. That's what we're doing. Okay, and you're like, well, I don't know. I'm new here, I don't know. So here's my base, here's my amount, right? Here's my base, here's my amount. And again, you could graph this, you could estimate it, you could do a lot of things, but also we could do change of base. So what is going to happen is I'm going to say, okay, my big number, log of 2 is my numerator, divide by log of 3, which is my denominator. And then I'm going to get a decimal, actually. So I'm sorry about that, but you know what? So we're doing the best we can with what we got. Okay, so the outcome, that equals, and it needs to be smaller. Okay, 0.63. So x equals 0.63. So now what you can say, you can write log base 3 of 2 equals 0.63, and 3 raised to the 0.63 power equals 2. Those are two powerful statements that you can say now that you know the answer. So that's what we're doing. We're just solving for x. Right? Yeah? Okay. That's it. I hope you have fun and don't stress because there's always YouTube. Yeah? Okay. Bye.